Hi Rockridge, this is Mrs. Berger, and today this little video lesson will run through the books chapter 4.5, and this is what we're calling Unit 4, Day 2, Part B. We're going to talk about some tree diagrams. I know you've seen these before in past classes in math. So if we think back to the probability of rolling a die once and then rolling a die twice, what is the probability that you'll roll a 5 the first time and then you'll roll a 5 again? Remember, when you roll a die twice, there are 36 different outcomes. Remember, we had an outcome where you could roll a 1 and then a 1, a 1 and then a 2, 1 and then a 3, and so on and so forth. And one of those choices was a 5 and then a 5. And so out of those 36 different outcomes, one of them is a 5 and then a 5, and so that's why that's the probability of rolling a 5 and then a 5. There are 36 different outcomes for a roll, 2 rolls of a die, and only one of those is rolling a 5 and then another 5. If we were asked to draw a tree diagram in probability and statistics for the 2 rolls of a fair die, this is what that tree diagram would look like. Okay, tree diagrams always start with a single point where we've not taken any action, and then the first set of branches of the tree for this particular example, will indicate roll number 1, and we know that roll number 1 can have these different outcomes: a 1, a 2, a 3, and so on. And the probability of rolling each of those is a 1 in 6 probability, so we indicate that probability. Sometimes we do it in fractions, sometimes we do it in decimals. In this case, it makes more sense to do 1 in 6, 1 in 6, 1 in 6. So all of those probabilities of each of those different outcomes for that first roll all add to 1. Now, one of the biggest mistakes students make when they're drawing a tree diagram is when they roll the second die, or when they roll the die for the second time, they go start another tree, and that's not proper. We should stay within the same tree. Okay, you're stuck with your first roll. Think of it that way. Okay, so if you're in Vegas and you rolled a 1, you're stuck with that. Okay, and so from that point, after you roll the 1, you roll again. So roll number 2 happens, and at the bottom of this tree, you'll see that there are 36 different outcomes, right? So this is the outcome of a 1 and then a 1. This is the outcome of a 1 and then a 2, and then so on and so forth. Each of these probabilities on these lines is also 1 in 6, 1 in 6, 1 in 6, right? So those all add to 1 as well. So this was just an example to show you how to properly draw a tree diagram showing the probabilities all along the way. Okay? Only draw one tree. Don't be drawing more than one tree for your scenario. Let's do another one, and we're going to base this on our favorite data, the data of the male athletes in the room. I have that example data that you probably still have in your notes from the last video. And we're going to draw a tree diagram to represent that. So we've done a two-way table, we've done a Venn diagram, and now we're going to do a tree diagram. And you can always do a tree diagram from top to bottom or left to right. This one, just to show something different, we'll go left to right. So we start off with the do-nothing scenario. We have not done anything yet. We haven't divided anybody into anything yet. And if we look at our data, if you remember back to our data, we had 13 males and 13 females. So if we first divvy the room up into male and female, 13 out of 26 and 13 out of 26, that means we have 50% male and 50% female. So the probability of randomly selecting a male, randomly selecting a female is the same. In our particular example, it's 50-50. And then in our particular example, within the males, the conditional probabilities of within the males, we had some athletes and some not athletes, right? Again, this is all within the same tree, so don't start another tree for the athlete, not athlete. We're still within the same tree. And we had the same split for the females. We had athletes and not athletes. And within each of those, we had some numbers. And if we took the probabilities within, given you have a male population in that room, you have a 77% chance. I'm not going to make you do the math and go back to the table, but based on our data before, 77% chance that that male is an athlete, and only 23% chance that they're not an athlete. Okay? And so again, once you have selected the males, you now have 100% males. Within those males, with the condition of male being met, you now have a 77% chance that they're an athlete, or 23% chance of not athlete. Similarly, on the female side, the split was 62% and 38%, which of course those two numbers add to 100% of our females. Okay, and so you can see now we've seen the two-way table, we've seen the Venn diagram, now we've seen the tree diagram. A tree diagram is super useful for getting us these conditional probabilities. Okay, so let's take a look at this question that we're asked here. Calculate the probability of randomly selecting a classmate who is an athlete given she is a female. Look how easy this is going to be to answer now that we have this tree diagram. Given she is a female, what's the probability of selecting an athlete? 62%. Okay. So, definitely want you to understand how to properly make a tree diagram as well as analyze a tree diagram. Let's take a look at number 5 on your practice. We're going to do number 5 and number 6 together here, and then I'm going to want you to take number 7 and try that on your own for homework. So number 5, suppose 10% of adults belong to a gym. 40% of these gym members go to the gym twice a week, at least twice a week. Find the probability that a randomly selected adult belongs to a gym and goes there twice a week. Now, why can't we just say 40%? 40% go to the gym twice a week. Because it's not 40% of all adults, it's 40% of the 10% that go to the gym. Okay? So to find this, we're going to take the probability, and let's go ahead and name these. So probability of going to the gym I'm going to call G, and probability of going at least twice a week I'm just going to call W. So the probability of going to the gym, or 10%, times the probability that you go twice a week, that was 40%. If we were to multiply those together, you would get only 4% of all adults go to the gym and go there at least twice a week. Okay? So if you're presented with one of these questions, go back and take a look at one of the, make sure you practice this before taking a quiz or test. Make sure you understand how to interpret question number 5. Question number 6, and this you may recall questions like this from your Algebra 2 class. A stats class with 30 students, it has 10 males and 20 females. You're going to choose one student and put them in the hallway, leave that student in the hallway, and you're going to come back and take another student and put them in the hallway. You're going to find the probability that both those people you put in the hall are female. Okay? You might have recalled this type of question from Algebra 2. It was usually with a deck of cards, right? So you took a card out of the deck, and you looked at it, and you said, what's the probability that it's an ace? And then you did not replace the card. And you pulled another card, and you wanted to know the probability that both of them would be aces. Okay? So this is without replacement. If you recall that terminology from Algebra 2, without replacement, we're not putting the person back in the room. Okay, without replacement. So now, the probability that both are female is found by finding the probability that the first person is female times the probability that the second person is female. Probably that the first person is female, there's 30 people in the room, and 20 of them are female. So that's your probability of randomly getting a female. Once you take that person and put them in the hallway, you only have 29 people left in the room. And if you pulled a female the first time, you only have 19 females left to choose from. Okay? So again, this should remind you of the problems where we had a deck of cards. So if you were to multiply this out, you would get 0.437. This, of course, is not the key to solving these problems. The setup is where you would earn most of your points, but obviously we do want to go ahead, just for curiosity's sake, and realize that there's a 43.7% chance of randomly selecting 2 females in that particular room. Okay? Alright, so that is our lesson for Part B. Short and sweet and simple. Do take your time on question number 7 and come to us with questions.